Hello class. In this video I'm going to go over how to build a very simple C# file processing application using Windows Form applications. And then I want to talk about, the first part of this video we'll just talk about the basic steps for building a file processing application. And then I will go through an example from scratch where we build this type of application. Just a heads up, I'm recording this video in the middle of a big thunderstorm, so you may hear some rumbles and rain as we go. All right. When we are building a GUI for our file processing application, there are some basic controls we may want to add that will make our life easier. First of all, we want to add a file dialog control. We do not want our application to force the user to be manually entering in file names. That's a sloppy input, easily to type things incorrectly. So we want to use a control that allows the user to search your computer to find the file that they want to process and extract the file path from the control. So we're going to use a dialog for that. Also, when you're doing file processing, you are often spitting out a bunch of data. Now you can also save results to output files, but I like to use a rich text box control because it allows you to put multi-line data, gives you a large kind of text output control to just display results. Now, depending on the type of processing we need to do, we may need to add additional inputs to allow the user to enter in search names or numeric values or set criteria on how we want to process the file. So depending on the types of file processing you're doing, we may need to add additional controls that the user can manipulate and will influence our processing algorithm behind the scenes. All right. Here, what I've tried to do is I've tried to outline kind of your general event handler steps when you want to process a text file. All right, and I try to list the steps in approximately the order you may want to implement each of these components. So first of all, when your event handler is called, I like to clear out all old inputs, or outputs I mean. Clear out the old outputs, clear any error statuses. If you're using color indicators to indicate that something has occurred, reset the color indicators. Basically, when you click the button to process the file, if you have previously processed a file, you want to make sure all of the old processing information is gone before you start building your new, writing your new outputs. Next, you need to make sure all your inputs are okay. So verify that a valid file path has been selected. You can't open a file that hasn't been selected. You can't read through a file that hasn't been selected. So verify that a file path has been selected. If your file processing requires additional inputs, check all your inputs and make sure that those inputs are set to valid ranges. And then after you've validated your file path and your inputs, then it's time to read in all the input values from the form. Create any accumulators you may need in your file processing loop. And then once you've set those components up, you're ready to open the file and start reading over the file. So then I have a step for opening a connection to the file. Here we have our file processing loop where we read each line, process each line. When we are finished with our processing, we close the connection to the file and report our results. Now sometimes while you're processing the file, you may want to report some results. I'm going to go over two examples where we can report results while we are processing and how to compile a set of data that you can report afterwards. Okay. You don't have to always follow these steps in this order. Again, this is just a general guide. Now let's focus on this step 7, the file processing loop. What does that look like? Well, here I've tried to kind of break that down into some general pieces. When you want to process a text file, first thing you need to do is read the line. Then what I like to do is if there are any comment lines or lines that we need to ignore, like a header line, I set the logic to ignore those lines. Then all of the other lines that we want to process, if they require any cleaning or modifying, we clean up the data. Once our lines look clean, then we can break the line, split the line up into its components. the types of text files you most commonly will be interacting with are text files in the CSV format, which stands for comma separated values. And CSV files are very easy to break up into their components. So we'll split a line into its elements, pull off the pieces from that split array that we need. Often when you are processing a data file, you may not need all the information in the file. You may just need, the first column value and the third column value. So you extract the key values from the line, and then you are ready to implement your processing algorithm. Common processing work requires or involves filtering, meaning maybe we only want to deal with a certain part of this data set, certain lines, and then accumulator work, averaging, counting, maxes and mins, summing, that type of thing. All right. So what I've tried to outline are just the basic general steps that you want to think about when you are setting up a file processing application. Now to practice this, we're going to use the following data set. I have a data set that involves candy, Halloween candy. And the data set looks like this. It's just a text file, a CSV text file. And this text file has an opening line that contains the names of all the column values in the file. So we have a candy name, a chocolate attribute, fruity attribute, caramel, etc. And then we have a sugar percentage, a price percentage, a win percentage. This particular data set was testing different candies against other candies in a head-to-head matchup, and this win percentage tells you how often did our candy win against other candies, how popular it is. If we look at after the header line, if we look at the rest of the lines, we see that we have data. So for the first column value, before the comma, we have the name of the candy. The second column value, we have a 1 or a 0. A 1 indicates that this attribute applies to the candy. A 0 means it does not. So if I look at 100 grand, the 0, 1, the chocolate column, we have a 1 here, so 100 grand is chocolatey. And then the 0, 1, 2 column, fruity, we notice that we have a 0 here. That means 100 grand candy is not fruity. So each of these columns represent kind of an attribute of this candy. All right, and then from this data set, I have 5 questions. I want to see if I can extract this information from the data set. Question number 1 says print all of the candy names of all the hard, fruity candy. Question number 2 says print the number of chocolate candy found. Problem 3 says what is the average sugar percentage of all caramel candy? And then 4 and 5 are going to require additional user input values. So number 4 is going to have the user enter in a candy name. And if we find that candy name in the data set, we're going to print the candy name, the sugar percentage, price percentage, and win percentage. The last question is going to allow the user to enter in a sugar percentage value, and we're going to list all of the candies with a lower sugar percentage than the percentage entered. Okay, so this is a nice little assortment of questions. The first question is just a filtering question. We only want to print the names under certain conditions. The second and third are accumulator type questions. Question 2 is asking a how many. Question 3 is asking an average. And then 4 and 5 are going to require us to read in additional user input before we process the file. All right. I'm going to go ahead and bring up our data set again. We will reference this data set a couple times while we build our algorithms. But here I'm going to pull up a blank Windows Form application, and let's just get started. I'm going to try to follow the steps that I outlined in my document. All right. To get started, I'm going to open up my toolbox so I can grab some controls. And some of the controls I'm going to want to add are a open file dialog. So I'm going to first add my dialog. I'm going to use an open file dialog. This dialog is going to be a control that allows me to navigate through my operating system and find the file I want to process. And I will be able to remove the file path to that file in my form application. Next thing I'm going to do is I'm going to add a rich text box. This rich text box is going to allow me to have just a nice big text space where I can output results. Okay, so we have a rich text box. We'll make it bigger and make it kind of fit nicely in just a moment. Now I need a control that allows me to actually create that open file dialog. So why don't we just use some buttons here? We could use a menu bar, but we'll just keep it simple right now. We'll try to minimize the amount of controls we are using, since this is supposed to be a basic application. So I'm going to select a button. This is my button 1. And what I'm going to do is I'm going to find my button 1. We're going to make this text of my button 1 say, how about select a file? All right, so we have a file select button, and then we're going to make another button. And this second button we are going to name process file. And I have 5 questions that we are working through. I could create multiple buttons that would execute each process, but I'm going to try to do all of the file processing in this using this one button click. So you click this button, I'm going to display the results of all 5 of those questions that we have asked. Okay. All right, let's make my rich text box a little bit bigger here. Try to shrink my form down so that it just fits my screen a little better. There we go. So very simple form so far, minimal controls. All right, let's see if we can make these controls do something. So I need to be able to select a file and then process the file. So I'm going to register a click event handler for my first button. So I'm going to double click on my select file control. And I'm going to put a little note here. This is where we want to use the open file dialog object in our button 1 click event handler. Minimize my toolbox there so we can see some more real estate. All right, so my button 1 is going to allow me to open a file and select a file. My button 2 is going to be the processing, so I'm going to double click on my second button to register a click event handler for my second control. And this second control is going to be processing the file. All right. And now I need to get a file name from my first event handler to my second event handler, so I'm going to create a private field in my form class to hold the file path. So I'm going to say private string file path. And then just to keep things simple, what I'm going to do is I'm going to initialize my file path to an empty string in the constructor. And in my button event button 1 click handler where I want to open the file dialog, my logic is going to say if the user selects a file, change this file path from an empty string to the actual file that was selected. Otherwise, make sure that the file path is an empty string. Many ways we could create this logic, but let's just try to make this happen. All right, from my open file dialog object, I'm going to call the show dialog method. Show dialog method is going to create the dialog window that I can then search for my file. The show dialog method returns a dialog result value, and so I'm going to save that result to a variable. So I'm going to create a dialog result variable called dr, and this is going to save the status. If I return from the show dialog with a file selected, it's going to return a dialog result OK value. If it does not, it's going to return a dialog result cancel or some other dialog result enumerated value. So what I can do is I can say, well, if that dialog result value is equal to dialog result OK, this means the user selected a valid file. So I'm going to say the file path is equal to, I'm going to grab the file name property from my open file dialog object. All right. Show dialog allows the user to start navigating. When they select a file, it's going to be the path to that file will be stored in the file name property, and then I'm grabbing the property from the dialog and bringing it into my application. And if the file path was not if the user did not choose a file from this dialog, then I want to make sure that that file path is still an empty string. So I'm going to do a little if-else logic here that says if a valid file path was selected, grab it from the dialog, save it into my file path variable. Otherwise, make sure my file path is still an empty string. Okay. Now it's time to start our processing button. So the first button is just all we are using the first button for is to grab the path to a file from our computer, bring it into our application. Now, processing the file, we're going to follow through some of those steps that I mentioned before, and I'm going to kind of write those steps out again here. So step 1, I think I said clear out old output values. And so since I'm using a rich text box, I'm going to call the rich text box .clear method that will just delete any text that was previously printed to the rich text box. All right, step 2, I believe I said verify that a valid file path was selected. Well, the way we set up our file path variable here, our little local, our field variable, is the field variable will either be empty string or a valid file name. So I can say, well, if the file path variable is equal to an empty string, that means no file was selected. So I'm going to say messagebox.show no file selected, and then return. I put a return statement here because there's no reason for me to keep processing this file if no file path was selected. So the return just exits our event handler method early and gives control back to the user. All right, step 3, I believe we said verify additional inputs. We haven't, when we get to problem number 4 and 5, question 4 and 5, we're going to add some additional controls. But right now we don't have any additional controls, so we'll just leave this blank for now. We'll come back to this. Step 4 said read input values from the form. Again, we don't have any additional inputs, so we will skip this step for now. Number 5, we said declare necessary accumulators. Well, we will fill that in as we need to. Step 6, we said open. We're ready to open a connection to the file. Open a connection to the file. I'm going to use the stream reader object to open a connection to this file that was selected up here. And if we want to add the stream reader object, if we want to use the stream reader object, that object is inside the system.io namespace. So I'm going to add the system.io namespace to my application. This is the home of the stream reader class and the stream writer class if we wanted to write output data to a file. So I'm adding this using system.io, and that's going to allow me to do the following. So I can say stream reader SR is equal to a new stream reader. So I'm going to instantiate a stream reader object and pass in the valid file path that was selected. All right. Now, step 7. Just going right down the list. Step 7, we want to create our file processing loop. So create file processing loop. And that file processing loop might look something like this. We're going to set up a while loop that says while we have not reached the end of stream, while we have not reached the end of the file, the stream reader has a property called end of stream, which becomes true when we reach the end of the file. So as long as we haven't reached the end of the file, end of stream should be false, not false is true. So we want to keep looping while we have not reached the end of the file. Another way to write this would be while sr.end of stream is equal to false, just to put it explicitly. While the end of stream property is still false, we want to keep doing our processing. Now inside this loop, we're going to read each line, and we're going to process each line. And we'll fill that in with our second page of notes, the processing part, in just a moment. But after we're done with the processing loop, then what we can do is we can close the connection to the file, which is just sr.close. And then finally, the last step was report results. And as we get results, we will fill this in. All right, let me just slowly kind of walk through this so you can kind of see the framework I'm setting up. So we're clearing out the old values, making sure we have a valid file selected, grab additional inputs. We will see that in a moment. Open a connection to the file, read each line of the file, close our connection to the file. Okay, this is just a basic framework for setting up a file processing application. All right, now comes the custom work. So now we have some questions we have to answer. Well, no, you know what? Let's fill in some of the processing steps. This was the second slide I showed. So that when we process each line, I'll use A's and B's and C's for this one. So we said step A in the file processing guidelines, we said step A is read each line. Step B, we said something about ignore header lines. And then step C, we had clean the line data. Step D, we said split line into elements. Step E, we said extract key values. Step F, we said finally implement our processing algorithms. And now by using comments and kind of listing all the steps here, this is going to help me organize my code when I'm ready to process the file. Also, when you start with a guideline like this, it kind of helps you make sure that you're not forgetting any steps. Like, if I'm not thinking about ignoring header lines, I might write some algorithms that parse data in such a way that my program will crash when I parse the header line. Things like that. Okay, we might not have to do all of these components, but we want to think about them. All right, let's talk about our first question. Our first question said, print the names of all the hard, fruity candy. Print the names of all the hard, fruity candy. Well, we have to go back to our data set. And you will never be able to extract information from a file unless you understand how that data is stored in the file. Okay, you have to understand the data layout before you can come up with a strategy to extract it. So if I want to print the names of all hard fruity candy in this file, I want to kind of find out where the key values I need to extract are the name, because I have to print the name. We're looking for fruity candy, so I have to extract whether the candy is fruity or not. And we're looking for hard candy, so if I scroll through my column header here, I see that one of the column attributes is hard. So I see a hard attribute, fruity attribute, and a name attribute. Okay? Now, I need to know the index of each of these values, because after I split my line into its components, to extract the name and the fruity and the hard values, I have to know their location after we split this line into its components. So if I look here, name is index 0, then 1, 2, fruity is index 2, and then 3, 4, 5, 6, 7, hard is index 7. Name is index 0, fruity is 2, hard is index 7. Okay, so let's see. We already have our file reading and writing process kind of, we have the shell of it created. Let's actually make this work now. So to read each line, I'm going to say, I'm going to create a temporary string variable called line and set it equal to sr.readLine. I'm taking my stream reader, reading the first line from the file, saving it into a little string. Okay. Now let's talk about headers. How do I ignore headers? Well, this header line starts with the string of text competitor name. So what I'm going to do is I'm going to grab that string of text, bring it into my application here, and I'm going to build just a little piece of logic. I'm going to say, well, if that line starts with the string competitor name, continue. Continue means we stay in the loop, but we skip the rest. We exit the loop here, and then we go back to the loop condition. So we're going to skip future processing if the line starts with competitor name. If it doesn't, we will continue on with our application. Reading a line, ignoring the header. Now cleaning the data. Right now, I don't think this data set is really a dirty data set. It looks like all of the status values are 0. It looks like all of our line data, our status attribute values are 0s and 1s, and then our 3 percentage values look like just double values. So I don't see any dollar signs or any weird characters in here that I have to clean. So cleaning line data, I don't think we need to do anything here. I think we're ready to split. So to split the line into its components, I'm going to call the split method. So I'm going to create a string array called data on the left-hand side and set that equal to line.split. And I'm going to split on a comma character. Now this split method takes a character data type, so notice the single quotes here. We can only split on a single character. And it's going to return a string array. This line is just a string of text, so it's going to break each substring based on the comma and store each of those values in an array where the comma is what separates each value. Okay, so we're splitting the line into its components. Now we want to extract the key values. There were 3 key values we were dealing with for question 1. We needed the name, we needed the fruity status, and we needed the hard status. And we said, well, the name was going to be data at index 0. And we said the fruity status was saved at data at index 2. And the hard status was saved at data at index 7. Now each of these values is going to be string values. So this is going to be some name value as a string. Let's put this as a comment. Okay, the format of the fruity status is either going to be a 0 or a 1. Now even though this is an integer 0 and integer 1, it's just representing true or false. So I don't have to parse this into an actual integer in this case. I'm not doing math with this number. I'm just using it as an indicator. Is this candy fruity or not? And the same with the hard status. It's just going to be in the format either a 0 or a 1. Okay. So read a line, ignore the header, split that line into its components, grab the 3 values that we need to do our work, and now let's implement a processing algorithm. So question 1 said print the names of hard fruity candy. So I'm going to say, well, if the fruity value that I grabbed from this line is equal to 1, and the hard value that I grabbed from this line is also 1, then I'm going to append, let's grab my rich text box, I'm going to append the name plus a new line to the file. So I'm going to say, let's append something at the beginning that maybe says hard fruity candy, and then we'll list the results. And that's it. The actual algorithm that does the work is usually very simple. Okay, as long as we've extracted the components we need, we can just use those values in some pretty simple logic to get the results. Now in this case, I'm not reporting the results after the fact. I'm kind of printing the results to the rich text box as I find them. In a later example, I will show you how we could save the results and then report them afterwards. But let's run this program. Let's see if it crashes or works. All right, here's my form. I'm going to select a file. In my downloads, I have a candy.csv. And then when I process it, we see, oh, I'm printing hard fruity candy way too many times. That's not good. Okay, so I need to print that hard fruity candy before I process the loop. Okay, because as I read through each line, I don't want to print hard fruity candy every single time. Just want to print that once. And then as I find the hard fruity candy, we will append that. Let's try this again. Select the file, candy, process. So we see the hard fruity candy, we got Dum Dums, Fun Dips, etc. Okay. Okay. Question number 2. Question number 2 says, let's write it down real quick. Question number 2 says, print the number of chocolate candies found. So printing how many chocolate candies, this is a counting operation. This is an accumulator operation. So what do I need to solve this problem? Let's look at the data set. Well, I need to know how many of these candies are chocolate. So I really am just going to say, well, how many lines have the number 1 in the 0, 1 index, right? So I need to be able to extract another key value from this line of attributes. I need the chocolate value. I also need to set up a counting accumulator so I can count them. So let's do these 2 pieces. So first of all, up here where I have a little spot for my accumulators, I'm going to create a variable called chocolate count, choc count, and initialize it to 0. Then we need to extract that chocolate value. So here I'm going to say string chocolate is equal to data at index 1. And it is also going to be a 0 or 1 value that I'm extracting from my string. So I added an accumulator, extracted an extra key value so I could solve this problem. And now to do the actual work here, I could say, well, if the chocolate value if the chocolate value from this line is equal to 1, then I should count it. So I'll put a little counter here, my chocolate count plus plus. And that's it. That's all we have to do. Okay, if we find chocolate, we count it. Now here, when we are accumulating, I don't want to put my output, I don't want to print how many chocolates I had until I have finished counting every line in this file. So after my while loop here. So I'm going to go down to line 9 here, and I'm going to do the following. I'm going to say rich text box 1 dot append text. Well, let's do a quick little bit of logic here. I'm going to say, well, if chocolate count is equal to 0, that means we didn't count. There were no chocolate candies in this file. So let's build that really quickly. I'm going to say rich text box 1 dot append text, no chocolate candy found. Put a little new line there. I'm going to put a new line before it as well so we can kind of separate each of these reported results by a new line. If that chocolate count is not 0, then hopefully it is greater than 0. So we'll say otherwise I'm going to output this many chocolate candy found. And let's insert our chocolate count. So reporting the results. So summarize. Created an accumulator before the loop for our counter. Extracted the value we wanted to count from the line. If that value that we extracted is 1, increment our counter. After the loop, print the results. All right. What do you not like here? Oh, I have to do a string dot format. If I want to insert a numeric or a value into my formatted string, I need my string dot format syntax here. All right, let's test it out. Here we'll select a file, select our candy file, process the file, and we found 37 chocolate candies in this data set. All right, let's look at number 3. 3 is kind of just another variation of the accumulator work. 3 says, what is the average sugar percentage of caramel candy? So I have to filter out caramels and then average the sugar percentage. Let's look at the data set. Here the sugar percentage is the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, index 10 value here. And if I look at the format of it, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that sugar percentage looks like it's a double value. Now I do need to do math. I need to average these sugar values. I do need to do math, so I'm going to have to convert this string value into an actual double value. So sugar percent is at index 10, but I only want to average the sugar percentage of caramel candy. So I need to pull the caramel value as well, which is index 0, 1, 2, 3. 3 is caramel, index 10 is the sugar percentage. All right, let's make this happen. All right, when we are extracting values, we're going to extract string caramel is data at index 3, which is also just 0 and 1 format. And then we also said, well, I need the double sugar percentage, say sugar percent, and that was stored at data at index 10, but data at index 10 is a string of a double value, so it's going to be like 0.123, something like this. So I'm going to take that string value stored in my data array and parse it. So I'm going to say double.parse, convert that string into a double, and then save the actual numeric result. Okay, so I'm extracting the new two values, caramel and sugar percentage. Now I need to find an average sugar percentage, so I need some more accumulators. To find an average, I need a counter, so I'm going to call this caramel count, carm count, how about? And I need to sum the sugar percentage, so I'm going to maybe say double, how about caramel sugar sum. Okay, I need to sum all of the sugars and then divide it by how many caramels we have. Okay. Now that we've extracted all the values and set up our accumulators, the logic to solve this problem is fairly simple. I'm going to say, well, if the caramel value, that we pulled from this line is 1, then I'm going to say, well, my sugar percent, no, what is it called? It was caramel sugar sum. We're going to add the sugar percent value. This sugar percent value is the value we extracted from the line. So I'm going to sum all of those, and I'm going to count. So my caramel count, increment it by 1, and that's it. So to find the average, I just divide sugar percent by caramel count. So let's display the results here. So I'm going to say, well, if that caramel count is equal to 0, well, then we did not find any caramel. So I'm going to say rich text box 1.append text. We'll say no caramel candy found. Otherwise, we know we found something, so we're going to show the average. So we're going to append string.format average sugar percentage of caramel candy is, and we'll format this as a P, :P for percentage. Percentage takes our value, multiplies it by 100, and adds a percent sign at the end. And I'm going to pass in my caramel sugar sum divided by my caramel count. All right, make sure we put a little new line at the end. Let's look at this syntax together before we test it. Okay. Run it, test it. All right, select the file, candy.csv, process the file, and we see the average sugar percentage of caramel candy is 61.91%. So caramel candy is pretty sugary. All right. Question 4 says, add a control that allows the user to search for a candy name. If this candy is found, we want to print the name, sugar percentage, price percentage, and win percentage. Otherwise, print no candy found. So we have an additional filtering that we need to do, a search filtering. So I'm going to have to pop up my toolbox here, and we're going to add another control here, an input. So I'm going to grab a label, and that label I'm going to make it say enter candy name. Maybe we can shrink this form just a little bit, or the rich text box just a little bit. Now I'm going to grab an input text box, just a regular text box I mean. and allow the user to enter in a name. So when we process the file, we will hopefully, they will give us some name that we can then search our candy set, search for in our candy set. Okay. Now that we've added an input control, we're going to kind of fill in some of these additional steps. Well, now we have a name, a candy name, a search name that we need to deal with. So I'm going to go up here to step 3. We verify in our file path. Let's make sure that the user entered in a name that we can search for when we process our file. So let's do the following. I'm going to say, well, if text box 1, this is the control where the user is going to type in their search value. If text box 1.text, and I'm going to put a little .trim at the end. .trim is going to get rid of any extra white space characters that might have accidentally been entered before the search term or after. I'm going to say if that is equal to an empty string, then I'm going to assume the user is not trying to search for anything. They entered no value. So I'm going to pop up a warning, message box.show, enter a search name. And then just to make it a little easier for the user, I'm going to take the text box 1 and set focus to that control. That's going to make a blinking cursor occur in that text box. And then I'm going to return. There's no need to process further if the user hasn't given us this input. Okay. Now step 4, we can fill in step 4. If this is not equal to an empty string, that means the user entered in a value, so let's store that value. Let's read it from the input. So I'm going to create a string variable called, how about search name, and set it equal to textbox1.text.trim. And again, the trim is just a little bit of extra help. If the user accidentally searched for nerds and then put a space, there's a good chance we would not find a match on nerds and a space exactly. But trimming out that white space, that space characters, will make sure I'm searching just the text, the printable text, and nothing else. So we're gonna test this new input, read it in after we know we have something in there. And now we said we already are reading the name. What other key values do we need? Well, we wanted to print for each candy found. I wanted to print the sugar percentage, which I have, but I also wanted to print the price percentage and win percentage. Price percent and win percent. So that's index 11 and 12 respectively. Both of these percentages are just double values. So what I'm going to do is we're just going to kind of copy the step we did to grab the sugar percent and grab the others. So I'm going to say double price percent. That's at index 11. And then we said double win percent was at index 12. So just grabbing a couple more of those values from the line. I mean, I could grab, at the beginning, I could just grab everything from the line if I wanted to, and then just process it as needed. All right. So I think I have all the pieces we need. I have the user input value in search name. I've grabbed some additional data to print out afterwards. Now, how do I know whether this value, whether this name was found in my data set? Well, I'm going to use a flag, a Boolean flag that tells me whether the name was found or not. And let me show you how we can set that up. This Boolean flag is going to be an accumulator. So up here in step 5 where I declare accumulators, I'm going to create a flag, Boolean flag called search name found. And I'm going to set it equal to false. Okay, so we're going to assume we don't find the name. All right. Search name found, set it equal to false. Now our processing logic for number 4 says print the name, search for all names in the file. And then we want to print the sugar percent, win percent, price percent value. So I can say, well, if that search name that we grabbed from the input, is equal to name. What is name? Name is the name we grabbed from the file. Okay, if the name on this line equals the name that was entered from the user, then I want to print it, right? But I don't want to, if I print it in my loop, like I was printing the names, the fruity hard candy names, I'm going to get a lot of like text overlapping each other, right? This is going to be printing line by line, this is going to be printing line by line. So instead, maybe what I want to do is I want to save all of these search names into maybe a list. And then afterwards, I can loop through my list and print the results. So that's what I'm going to do for this problem. Okay, I want to save all of the names, and then I will print the results later. So let's try something like this. So up in my accumulators, where are my accumulators? Whoops, we're outside here. Where I declare my accumulators, I'm going to create a list for the results. So I'm going to call this bool, nope, not bool. We're going to create a list of strings. I'm going to call this my search results and create a new list of string objects. And what I'm going to do is I'm just going to go ahead and if I find a match, I'm going to add a value to this string. I'm going to format the string value that I want to add, format the string that I would have printed, and just add it to my list. Okay, let's see if this works. All right. Here we're inside the file processing loop right here. We say, well, if the search name equals name, then I want to do the following. I'm going to call this a string. I'm going to call this a result and set it equal to string.format. I want to put a, I'm going to create a string that has the name of the matching of candy name. And then I'm going to insert the win percentage. Let's just put them in raw data. I'm going to say this is going to be the sugar percentage, the what's the next one? Sugar price percentage, and the win percentage. New line. And I'm going to insert the name, the sugar percent, the win price percent, and the win percent. Okay. So what am I doing here? I'm just, instead of printing this formatted string, I'm just saving it to a string variable. And then what I will do is I will add this string variable to my list. So I'm going to say my search results dot add this result. So I'm just compiling a list. Every time I find a match on the search name, create the string, add it to my list of results. Okay. Now to report the results, I could say, well, if my search, and then if I found a match, I want to set my search results Boolean flag, search name found, equal to true. So we're going to flag that we have found it. Now I'm never going to set this flag to false. I initialize to false right up here. But when I set the flag, we only need to find one match for us to know we found a match. So I'm going to say search, if search name found is true, then I'm going to print the results. So I'm going to say for each string result in my search results list, do a little loop by value here. I'm going to say rich text box 1 dot append text the result. And otherwise, maybe we could say, let's put a little title on this too. Whoops, rich text box 1 dot append text. We're going to say search by name results. And then we'll print the results. If that search name wasn't found, I'm just going to say no results found. So we're going to append text, no matches found. I don't need a new line here. All right, this one, my code is getting big enough that you may have kind of start feeling lost. So let's just try to go over these pieces. So the question said, search for all names in the file. User enters in a name, and I want to print all matching names plus their sugar, win, and price percentage. So to do this, we created a input, added an input where the user can enter in a value. We're going to test to see, make sure that text box isn't empty. If it's not, I'm going to grab the name from the input. I created a list to store all of the matching results, and a variable that I can flag, that I can set to true if I find a match. Then I extracted the additional values that I wanted to write in this output. And then our logic says, well, if the name of the line matches the search name, I'm going to create a string that contains the matching name, sugar percentage, win percentage, price percentage. I'm going to add that string result to my list of string results and set that flag to true. I really don't even need this flag, by the way. If I'm using a list, I could just say, well, if the list.count size is greater than 0, I know I have results. Otherwise, I don't. But anyway, if we see that flag was set to true, I'm going to just loop through each string in my string results list and print the results. All right, select a file, candy, process the file. Whoops, there's our protection. Enter a search name. I meant to do that. Let's type in, let's see, what might we type in to get a bunch of results? I'm going to search in Milky. Process the file. And it says, oh, no search results found. That's because I'm searching by, my logic here is looking for an exact match. A better way might be something like this. What if I say if name dot contains the search string, what was it called? Search name. Okay, so I want to see, does the value that the user typed in, is it any part of the actual name that I read from the file? And I'm going to do even a one step further. I'm going to make sure that capitalization doesn't matter. So I'm going to convert the name dot toLower and see if it contains the search name dot toLower. We're going to force both of those inputs to the same case before we do our search. Let's try this again. Now we select a file. I'm going to search for Milky, hit process. And now we found 3 results: Milky Way, Milky Way Midnight, Milky Way Simple Caramel. And we see their different percentages. Now if I type in, let's try another one, Skittles, process the file. We actually did find a Skittles. And if we go in here and we say, I don't know, we say carrots, process the file, we see that we have no matches found. All right, I know this video is getting long. Let's see, can we do that last question? All right, finally it says add a control that allows the user to enter in a sugar percentage value. Print the names of all candies with a sugar percentage lower than the value that's entered. So this will be a numeric entry. Let's go ahead and do it. All right, so there's a candy name. We want to enter in a sugar percentage. Sugar percentage is going to be a number between 0 and 1. So I'm going to use a numeric up down to make it simple on us. So here we're going to say sugar percent. And I'm going to add a numeric up down. Usually when you're thinking about percentages, you're thinking in terms of 0 to 100%. So I'm going to make sure that my numeric up down allows you to enter in, let's lock it into doubles. Increment by ones, maximum of 100, minimum of 0. So they can enter in a value from 0 to 100%. And then in my application, what we will do is we will take that value divided by 100 before we do our testing, our comparing. All right? So we have a second input here. So let's go back to our form. where we validate inputs, verify additional inputs. Well, this numeric up-down will always have some value entered into it. It enforces that a number value is present. So I don't need to do the verify step right here. I just need to read that input value from my numeric up-down. So I'm going to say int, let's just do this. We're going to say double search sugar percent is equal to numeric up-down 1, and I want to grab the value, and I want to divide it by 100. All right. Now the value property of a numeric up-down is data type decimal. I want to use it as a double, so I'm going to cast this to a double. And then there we go. So at step 4, where we are reading in values from the form, I'm just going to grab another value from the input from the form and bring it into my algorithm, my application. Now we want to just I'm filtering on this. I don't need to do any more accumulator work. Maybe I could do, but I do want to store the results. So I'm going to say, well, Boolean. We won't even use the Boolean. We'll just show you how we will use a list for the sugar match results equals a new list of type string. All right. And this time we will just use the size of the list to determine whether we found a match or not. So question 5, our final question. We want to say list all names of candy with lower sugar percent. So we can say, well, if the sugar percent that we grabbed from the line right here is less than the search sugar percent entered from the user, then we're going to create the result. So we're going to say string.format. Let's put the candy name and the sugar percent. Put a new line here and put the name and the sugar percent. So we're creating a formatted string, and then we're going to add it to our search sugar percent results. I can't remember the name of that variable. Sugar match results. So we're going to take our sugar match results list and add the result to the list. So again, notice that the actual logic to do the work is very simple for each of these questions. It's just setting up all the pieces so that you can do this simple algorithm. All right. Now we just need to print the results. So our last output here, we will say, all right, rich text box 1.append text, sugar percent results. And we will say, well, if, let's use the list name. So now we're saying sugar match results dot count. If the number of values in this list is greater than 0, we know we have a match. So for each string result in my sugar match results, we're going to append the result. All right. Otherwise, we'll just copy our little else syntax from above. Otherwise, no matches found. All right, let's test this out. All right, so we're going to enter in a name. We'll say carrots. Notice that when I click, we never tested that file dialog. What happens if I try to process the file without a file selected? Notice no file selected occurs. So we have to select the file first. Then we process the file, and we say sugar results found, no matches found. Because the sugar percentage I entered is so low, no candy was below that. Let's try 25%. Process it. Notice here all of the results we get. A dime and a quarter. Well, of course, if your Halloween candy is money, low on sugar, but notice that the sugar results for each of these candies is lower than 25%. And if I made this 10% and process the file, we get a smaller subset. All right. All right, long video, but we covered a lot of different types of questions and combinations of steps we need to do to solve and extract data from files. I hope this helps.